Hi, welcome. Thanks for joining us today. So today we're going to do a question on indices. In fact, it's not just one question. I want to share with you these different types of variation as much as possible. Think of that there are more variations than that, but I just want to focus on this main three. All right. So for the first one here, this will just be a multiplication that involves indices, and when you follow in respect of the order of operations, the first thing that you need to do is to basically uh, do the powers first, right? So you have to basically expand out all the brackets before you can cancel them. So cancel the common factors will come after all the brackets are expanded. Okay? So take note that when you have a whole bracket that's being squared, it means that every term within the bracket has to be squared as well. So this means that you have to use 2 to square. Then p power of 5 must square as well. And for those who get mixed up with indices, what p to the power of 5 square really means is basically you use p power of 5, you times another set of p power of 5, right? So when you do that, in law of indices, it says that when you have the same base p, basically the number will join up by adding. Yeah, if you times with the same base, the power will be basically adding to each other. So in this case, when you follow another law of indices in the bracket itself, you got to take note that with the bracket there, it means that the power has to multiply. So it means you got to use 5 times 2, which is 10. Right, so you do the same thing here in the numerator. You just power of 4 into every single term, which means all the powers have to multiply by 4. And for the denominator, one law of indices also states that if you have anything power of 0, the answer is always 1. Okay. Now, how does it, why does the law of indices work for anything power of 0 is always 1? Because when you use an example for, let's say, when you use q divided by q, right? That will mean that you use one set of q divided by another one set of q. So if you follow another law of indices, when you use the same base to divide, the power have to do a subtraction, right? And the answer of that is basically the same as when you cancel it, you only left with 1. Right, and most of the time the question will tell you to put the powers in a positive index. That means you don't want to see negative power. And how do you deal with negative power? Is to basically switch their position. So anything that is of negative is telling that the term does not belong there. So it has to go down and it will turn into a positive. Yeah. And likewise, after this step, there is also no other brackets for you to break open. So immediately in this step, you can choose to cancel if you see any factor, right? Which includes the p power of 4 here, and 4 and 18, one at the top, one at the bottom, they are both even numbers. You can divide that by 2. So that's all for now. So we will just keep the rest that is not being cancelled. Now, so like I said just now, the q to the power negative a will have to go down to the denominator, so the negative will become positive. All right, and lastly, we'll join the q cube and the qa together. They are multiplying. So when you multiply the same base, the power will add up, right? So that is 3 plus 8. Just to double check if your final answer could have any more simplest forms to that. If there is none, then that's all you have to do. All right, let's move on to the second question that there will be quite a couple of mixture here involving division and addition. Okay, so but then this question is made slightly easier without the need to change of base. Okay, sometimes it will give you a slightly more complicated question by giving you maybe a number here that is not 5, or maybe it give you a 25 or 125. To which that in order for you to be able to combine with the other term here, you have to make sure that the base becomes the same. And the common base that both of them can change into is 5 itself, right? So the first question here, I will immediately expand out the bracket into based on this perspective terms. There's a total of 3 terms that you need to look at right now. So the first one is -5 times 4. The second term here, if you have a square root, that would mean that you have to divide it by 2, right? Right, so then in the order of operations, you have to do divide first before plus. Remember, do not do the addition first, right? If you remember the order of operations that you learned before in Sec 1, all the brackets must be done first, followed by powers and roots. Only after you have finished these two, then you can do times and divide. And lastly, you do subtraction and addition. So make sure that all the top layers are already settled before you go to the bottom. Right? And of course, in each of the layer, if they are the same order, then you have to go from left to right. All right, so for the same base, right, when you divide, remember that the indices will be basically subtracting each other. All right, once you get something like that, we're going to put equal sign, then you can change it. Now, there's no law on indices that you can apply here with addition or subtraction. Some of the students got very mixed up after they try and learn a lot of indices, and they thought that perhaps they could join them together by adding a power or something. No, this doesn't work. Okay, so for addition and subtraction, you got to just do it the traditional way. And what I mean by traditional way is you find out what is the answer for 5 power of 4. But before that, whenever you have a negative index, remember it is telling that it doesn't belong there. So you got to move it into underneath from numerator into denominator. Any whole number will have a denominator of 1, right? So this will become 1 over 5 to the power of 4. Even though they say no calculator, but I expect us to know 5 power of 4 without doing some huge calculation, right? So we can just start with the calculator for this one. Then for the denominator here, it will be 5 power of 2. If you worry about the presentation, I think it's better to show the in-between step, which includes making it becomes a positive index first, and you move it under, then you change it into the actual. All right, so based on this, when you add or subtract fraction together, it's all about making the denominator the same. And the 25 got to multiply by another set of 25, so that they have a common 625, and you can then join the numerator, right? So 1 plus 25 is at the top, 25 here. 6 to 1, 6 to 5. All right, and I just checked the calculator that this is already the final answer. So that's it. Let me proceed to share the third one. Question C here. There's quite a lot of huge things going on, but we always prioritize the top one first. So we look at the bracket, and outside the bracket there is another power of -3 for the second bracket, right? For this upper top right corner here. So there's actually a shortcut that you can apply, and that is if you see a division of if you divide by a number that have a negative power here. All right, so the shortcut is that yeah, so where was I? I said that if you divide by a number that has a negative power here, there's a shortcut that you can apply if you involve a fraction, and the shortcut is, now first of all, when you change divide into times, you have to swap the divisor, right? That means that the numerator will go down and the denominator will go up. Now the second, if you have a negative power of -3, that has to be applied to both B and A, right? So this will result in the B and A need to change position again. so that you can change the negative power into a positive. So the overall shortcut that you can have is, if you want to immediately change divide to times, and then also at the same time change a negative power into a positive power, you will just need to basically reverse the divide into the times as well as remove the negative sign at the same time. Right? So if you don't understand that, you can always go the proper way, which is showing the in between. Just take one more step, right? Doesn't take that long. So I say again, when you change divide to times, you will need to swap the divisor once. And once you remove the negative power, you need to swap it back once again. So this double swap will basically just keep the fraction as it is, right? So we will just still keep the same thing, except after you do that, there will be no more negative power. So there is still a bracket that involves a power of 3 outside. I still need to expand that out, right? And then another thing that we can do at the same time, so that we don't have to go through too many of the tedious steps, is to basically move the negative power down into the denominator straight away, right? Negative power will basically goes down to turn into positive. All right, and then next for the second fraction here, just need to cube everything, which means the number, the y, and the x all will have a cube, right? And this is where some of the students might get mixed up also, because they will probably screw up their order of their operations when they deal with the number as well compared to the algebra. Now, when you use 3 to cube, this literally means you have to press 3 cube in the calculator, right? However, when you deal with the algebra expression, when you see something like that with a bracket, now I said in the previous sharing as well that when you use a negative number with a bracket, that these two numbers will basically be multiplying to each other, right? So you get a y in the power of -9, and the denominator you have a 2 that has to times 3 to become 6. Right, with this I don't need to put a bracket anymore, so I can release it from the bracket. And the next thing we can do again is to make it even simplified, that by removing the negative index. As much as possible, I want to get rid of the negative index as soon as possible, because first of all, it's not user friendly. We are not used to seeing that. And second, once you make it becomes positive, it makes things easier to cancel as well. Don't you think so? All right, so I noticed that in here there seems to be nothing that I can cancel. There's no common factor, right? Do not try and cancel between two things in the denominator. This is not how it works, right? You can't basically cancel if they are in the same position as the middle, because they are supposed to multiply together, right? You've got top times top together and the bottom times bottom together, isn't it? All right, so there's nothing else we can simplify, so that will be it. I will see you for the next one.